Volume refers to how much 3D space something takes up. So volume has length, height, and breadth, 3 dimensions. And that's why the units of volume are length units cubed. For example, decimeter cubed, which is also liter, or centimeter cubed, which is also milliliter. So a centimeter cubed would be a cube, which is like a 3-dimensional square, where each of the dimensions is 1 centimeter. 1 centimeter by 1 centimeter by 1 centimeter is a centimeter cubed, and that is a milliliter. A decimeter cubed would be 1 decimeter by 1 decimeter by 1 decimeter, making 1 decimeter cubed. Standard temperature and pressure, STP, means 0 degrees Celsius, which is the same as 273 Kelvin, and 101.3 kilopascals, which is the same as 1 atmosphere, and that's the pressure of the atmosphere, atmospheric pressure at sea level. And the reason why STP is important for us to understand volume of gases is that 1 mole of any gas, it doesn't matter whether it's hydrogen, helium, ammonia, water vapor, 1 mole of any gas has a volume of 22.4 decimeter cubed at standard temperature and pressure. Of course, that is ideal, so it's theoretical that every single kind of gas will have this volume at STP. There is a little bit of variation of the actual situation, the real gas, from this ideal theoretical situation. But for now, we are going to simplify matters to say that any gas, no matter what it is, if you have 1 mole of it, it will occupy a volume of 22.4 decimeters cubed at standard temperature and pressure. We can actually go further than that and say that 1 mole of any gas occupies the same volume at the same temperature and pressure. What does this mean? We might have hydrogen, we might have helium, we might have oxygen. These are different gases. Let's say we have a certain temperature and pressure, whatever that might be, let's say 20 degrees Celsius and 130 kilopascals. It's just an example. So if hydrogen, helium, and oxygen are all at 20 degrees Celsius and 130 kilopascals, then whatever volume the hydrogen takes up at that particular temperature and pressure will be the same volume, trying to make this block look the same size, the same volume that helium would take up, and that would be the same volume that oxygen would take up. Now, there are equations for calculating what that volume would be, and that you will still learn, but the point is that the volume would be the same for the 3 gases, even though they're different gases. As long as they have the same temperature and pressure as one another, the volume will be the same. Now, if that temperature happens to be 0 degrees Celsius, 273 Kelvin, and that pressure happens to be 101.3 kilopascals, standard pressure and standard temperature, STP, then that volume would be 22.4 decimeters cubed for all of the 3 gases and any other gas. So then X here would be equal to 22.4 decimeters cubed. At other temperatures and pressures, it wouldn't be 22.4 decimeters cubed, it would be something else, because gases expand when it becomes hotter and they are compressed. They take up less space when they are at a higher pressure. So at another temperature and another pressure, that particular volume would not be 22.4, but it would still be the same for hydrogen as it is for helium, as it is for oxygen under those particular conditions of temperature and pressure. And that's Avogadro's law.